Welcome to the Explainer. Today, we're going to break down trigonometry by looking at its most fundamental building blocks. You'll see how a few simple ratios, all coming from a basic right triangle, unlock this incredibly powerful way to measure the world around us. So let's start with a little thought experiment. How is it possible that knowing just one angle in a right triangle can totally lock in its shape? I mean, no matter how big or small you draw it, the shape stays the same. The answer to that is the key to everything.
Here's our plan. We'll learn the language of the triangle, find a really cool pattern, give those patterns names, put it all into practice with some solid examples, and then we'll wrap up with why this whole idea is such a game changer.
First up, we need to learn how to talk about a right triangle. And you're going to see pretty quickly that it all comes down to your point of view. Okay, so every right triangle has a few key parts. You've got the hypotenuse. That's always the longest side, right across from the 90-degree angle. That one's easy and never changes. But the other two sides, the opposite and adjacent legs, well, their names totally depend on which angle you're looking from, what we call our reference angle. And here's what's so cool about it. These labels, they're not permanent. They can actually swap places depending on where you're standing inside the triangle. Let's check out triangle ABC to see exactly what I mean. This table just nails the point. If we pick angle A as our home base, the side way across from it, BC, is our opposite. But if we walk over and stand at angle B, all of a sudden side AC is the one across from us, making it the opposite. It really does depend entirely on your point of view. So for our next part, let's see how this idea leads to something, well, kind of magical. We're going to see what happens when you compare triangles that are different sizes but have the exact same angles. Check this out. We've got three right triangles here, a small one, a medium one, and a big one. But they all share that same 53.1-degree angle. Now watch. If we take the opposite side and divide it by the hypotenuse for the first triangle, we get 4/5. Now do it for the second one. 8/10 is 4/5. And the third one, 16/20 is, you guessed it, 4/5. It's the same for every single ratio. And this isn't some crazy coincidence, it's just how geometry works. Because the triangles are similar, their sides are all in proportion. And this is the giant aha moment. For any specific angle you pick in a right triangle, the ratios of its side lengths will always be the same. This one idea is what trigonometry is built on. So naturally, since these ratios are so reliable and so important, mathematicians figured they probably deserved some official names. And here they are, the big three: sine, cosine, and tangent. Don't let the fancy names fool you. They're just labels for those patterns we just found. The sine of an angle, that's just the name for the ratio of opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. That's it. Okay, so how on earth do you remember which is which? Easy, with probably the most famous mnemonic in all of mathematics: SOH-CAH-TOA. Seriously, say it a few times. SOH-CAH-TOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. It's your cheat code. All right, enough with the theory. The best way to really get this is to just do it. So let's put SOH-CAH-TOA into action with a few examples. This will make it stick, I promise. Okay, first up, look at this triangle. We're going to use angle Z as our reference point. So, what's the sine of Z? Let's think. SOH. Sine is opposite over hypotenuse. All right, from Z, the side opposite is 28. The hypotenuse is the long one, that's 35. So, sine of Z is 28/35. And if you simplify that fraction, you get 4/5. Boom, done. Okay, same triangle, but now for a little twist. We're going to switch our point of view. Let's go stand at angle X. Now, what's the tangent of X? Think. SOH-CAH-TOA. Tangent is opposite over adjacent. So, from angle X's perspective, the opposite side is now 21, and the side next to it, the adjacent, is 28. So tangent of X is 21/28. Simplify that and you get 3/4. See? The moment we changed our reference angle, we got a totally different answer. It's all about perspective. All right, one more for good measure. New triangle, CAT. What's the cosine of angle C? Let's go to our mnemonic, CAH. Cosine is adjacent over hypotenuse. Okay, the side adjacent. I'll write next to angle C is 8. The hypotenuse is 17. So the cosine of C is just 8 over 17. That fraction doesn't simplify, so that's our final answer. You're getting the hang of this. Okay, let's bring it all home. Let's do a quick recap of the really big ideas we covered in this explainer.
So here are the key takeaways. Number 1, your point of view, the reference angle, is everything. It tells you what's opposite and what's adjacent. Number 2, the huge discovery. For any angle, those side ratios are always constant. And number 3, SOH-CAH-TOA is your best friend for remembering the formulas.
And that leaves us with one last thought. You know, we started today just labeling the sides of a triangle, but what we've actually done is unlock a whole new language. It's a language that lets us use angles to figure out distances we could never measure by hand. With these simple ratios, we can find the height of a building or even the distance to a star. So the only question left is, what are you going to measure first?